Hi everyone, this is a short video going over the lesson for Thursday, January 6th, if you were not able to make class today. So we started off the day with the do now again. So if you open up this do now, there are 3 questions pertaining to molecular formulas of chemical compounds that we talked about and reviewed yesterday in class. So here are what those 3 questions look like. First thing that you need to do is take a look at this chemical structure and figure out what elements are contained within this compound. Next, you have to count how many atoms of each element you see within the compound, and then use the information from the first 2 questions to write the molecular formula for the compound. Please note that the importance of practicing this skill is getting the formatting correctly. So remember, we have a certain way of formatting subscripts, and we have a certain way of formatting the chemical symbols within our molecular formulas, and you'll need to address both in order to get full credit. So after that really short do now, we're going to do 2 things in class today. First thing we're going to do is watch an Edpuzzle that discusses empirical and molecular formulas. And then we're going to do a couple practice questions applying what we learn in the Edpuzzle video. So the Edpuzzle video again talks about 2 different types of chemical formulas, one called molecular formulas and one called empirical formulas. Molecular formulas should sound familiar to you because these are the types of chemical formulas we've been discussing since late October. These formulas tell you how many atoms of each element are in one molecule of a compound. So here we have an example, ethene. If I count, I see 1, 2, 3, 4 atoms of carbon. So I'm going to start my formula with C4. And 1, 2, 3, 4, 5, 6, 7, 8 atoms of hydrogen. So my full molecular formula is C4H8. An empirical formula is slightly different. So this type of formula will tell you the simplest or most reduced ratio of elements in a compound. So once I found that the molecular formula for ethene was C4H8, I'm going to actually write out the ratio of different elements in that compound. So for every molecule, I'm going to have 4 carbon atoms and 8 hydrogen atoms. And so 4 to 8 is actually my ratio of carbon to hydrogen within this molecule. Just like you've done in math class before, we can reduce this ratio or this fraction into a 1 to 2 carbon to hydrogen ratio. And once I have this simplest or most reduced ratio, I can convert it into a new chemical formula called an empirical formula. So C4H8 and CH2 are both chemical formulas for ethene. One is a molecular formula and one is an empirical formula, and they tell us 2 different things about this molecule. So again, that concept is covered extensively in the Edpuzzle, and there are several examples in the Edpuzzle of converting from chemical structures to molecular formulas to empirical formulas. And after watching that video, you're going to have to convert between these things yourselves for 3 different compounds. Benzene, which is one of the primary ingredients in glue, nitrogen tetraoxide, which is a component of rocket fuel, and ethylene glycol, one of the most common chemicals used in paint. For each of these compounds, you're going to take a look at the chemical structures, and then type out the molecular formulas. Convert that molecular formula to an empirical formula. A reminder really quick that there are 2 different ways to create subscripts within chemical formula. So for example, if I wanted to write the chemical formula for water, H2O, I could do one of 2 things to make this to a subscript. I could press format, text, subscript, and that'll make my 2 into a subscript. Or I can highlight the 2, hold down the Control key, and then press the comma button. So that's Control plus the comma button. You don't actually touch the plus key, you just hold down the Control and the comma button at the same time. Please do make sure that your molecular and empirical formulas, again, are formatted properly with subscripts in their proper place and with the proper capitalization on chemical symbols. I mentioned this in class, but soon we are going to be talking about chemical equations, which will use coefficients or large numbers in a very different way than subscripts are used. So if you have been writing numbers just normally like this, H2O, without using a subscript, we are really going to have to get in the habit of changing that in the next month so that we're prepared to differentiate between subscripts and coefficients when we start equations. Okay. If you are in honors chemistry, you have already watched the Edpuzzle video that the college prep chemistry classes were watching today. So in your Schoology page, as soon as you complete the Do Now, you are going to start this molecular and empirical formula practice, which is a little bit more in depth and has some more questions. The questions are a little bit more challenging as well. So here is what that looks like. And of course, if you have any questions about the activity, please don't hesitate to let me know.